We're going to use cross multiplication, our knowledge of proportions, to solve for similar figures. It says the triangles below are similar. Use a proportion to determine the missing values. So you can see just by looking at the general shape of these that these are similar in shape. That means they are kind of the same. Doesn't mean they are the same, it means they're kind of the same. They are, there's a proportional relationship here. Now, if you take a look at it, you can see they're not the same size. Remember, proportions don't have to be the same size, they just have to be proportional. We've talked about this before, and so let's see what we can find out from this. It says, find the length of line RT. So let's see. Well, here's an R. Here's a T, and they want to know the measure of this line right here. How long is this line? We don't know. So I'm going to put an X there because I don't know that. I do know this one. I don't know that one, but they're not asking me about TW. They're going to ask me about that later on. Right now they just want to know this line right here. How can I find out how long that is? Well, let's look at this similar triangle. I have a side here, LN, and it is 15 feet long. I also have a side here, LP, and it is 18 feet long. And that corresponds with this line right here, which is 30 feet long. So I have 3 numbers, and I need to find out a 4th number. This is a proportion because these are similar. So first thing I'm going to do is I'm going to say my red sides are side 1, side 1. My blue sides are side 2. And I'm going to say this is figure 1, and this one here is figure 2. All right, so here's how I'm going to write this. I'm going to create a proportion of side 1 compared to side 2, and we're going to compare figure 1 to figure 2. So this is how we label it. Side 1 to side 2, figure 1 to figure 2. So let's take a look at that proportion and see if we can solve for that. So side 1, our side 1s are 15 and X. Our side 2s are 18 and 30. Notice my totals from, the lengths of my side from figure 1 are on the fraction bar for figure 1. So 15 to 18, side 1 to side 2, side 1 to side 2, 15 to 18 from figure 1. So figure 2, side 1 is X, side 2 is 30, so it's a ratio of X to 30. So my side 1s are on the same side of the fraction bar, my side 2s are on the same side of the fraction bar. My information from figure 1 is on the figure 1 ratio, and my information for figure 2 is on my figure 2 ratio. So now I have 15 to 18 is the same as, oops, better put my equal sign there, same as X to 30. And I can solve this like I've done with all my other ones. Not all my other ones, because obviously we've done several different ways of solving these. But the easiest way, most direct, is going to be cross multiplication to set up an equation. So I always start with my variable. 18 times X equals 15 times 30. And 15 times 30 is 450. Now I have to undo multiplication by division so I can isolate this variable. I'm going to divide both sides by 18. That cancels out, and I'm left with X equals 450 divided by 18. And 450 divided by 18 equals 25. And let's check the work here. And we're saying 18 times x. Oops, better try a different color so it's a little clearer. We're saying that 18 times x equals 450. And so it means we need to write it. 18 times blank equals 450. We need to check our work. We're saying that x, that's this blank, equals 25. So 18 times 25 does equal 450. So we are correct that x equals 25. So our proportion here, this here, is equal to 25. Let's take a look at the next problem. Now they want to know about the length of TW. TW is this one right here. So TW is this line right here, and it is similar to line NP here, which is 12 feet. So this, we'll call this side 1, and we'll call this side 1. We don't know what it is, so we'll call that X. And we have information on RT and on LP and RW. We have information, so we could choose. We could either use this line right here, and if we use that line, we have to use this line right here. Or we could, let's erase that real quick. We could also use this line right here and this line right here. Whatever you have to do, though, please pay attention that this corresponds with these two sides correspond with each other, and these two sides here, you do this in green, these two sides correspond with each other. So it doesn't matter which one you use. You can use this one and this one. Just make sure that it corresponds. So in this case, we'll just go ahead and use this right here, side 2 and side 2. So we are comparing side 1 to side 2, figure 1 to figure 2. So side 1 to side 2, and that's figure 1 to figure 2. Side 1, oop, you know what, I've got the wrong colors here. Let's fix that real quick. Side 1 is in blue this time, and side 2 is in red. So side 1 are these two sides right here, 12 and X. So 12 is side 1 from figure 1, so it goes here. X is side 1 from figure 2, so it goes here. And from side 2, 18 is side 2 from figure 1. Figure 1, side 2, 18. Figure 2, side 2 is 30. Figure 2, side 2 is 30. Once again, we can cross multiply. 18 times X is 18 times X. And then 12 times 30 is 360. We're going to isolate the variable. Divide both sides by 18 so we can isolate that variable. So we get the X all by itself. X equals 360 divided by 18, and that is 20. 360 divided by 18 equals 20. Then we rewrite the problem to see, we're saying that this is true, that here's our answer, X equals 20. Let's check our work. 18 times X equals 360. 18 times blank equals 360. And we're saying that X equals 20, so let's check that out. We have to do that. 18 times 20, and if we do the math, it does come out to, I'm not going to take the time to do that right now, it does come out to 360, but you actually have to do the math to prove it. Now it's asking about two rectangular boxes. So one of the best ways to do that is to draw a couple of rectangles. So we'll do that. Here's one rectangle, and we'll draw another one that's a little bit bigger. And we're going to say that these are similar. Alright, it says one box has a length of 24 inches and a width of 9 inches. The other box has a length of 16. So we'll make our bigger one 24. So it says a length of 24 and a width of 9. And the other one has a length of 16 and a width of, well, it doesn't say. It says what is its width, blank. Since these are actually closer in size, let's point out to you that these are probably bigger in size. There we go. We'll just leave it like that. All right. So that this here is a similar figure to this one right here. They're obviously not the same, but they are similar. And so we'll call this figure 1, and we'll call this figure 2. We'll call this side 1, and that means that's side 1 because notice they correspond. They're on the same side of different figures, and so these two sides correspond. This here is, we'll call this side 2. We'll call this side 2. So it's the same process as we've done before. Figure 1, figure 2, side 2, side 2, and side 1, side 1. Actually, we don't need to write those in. And we're saying these are equal to each other, and we fill in our information. Our information from figure 1 is x, because we don't know, and 16. And our figure here, side 2 is 24, and side 1 is 9. Again, cross multiply and solve. So it doesn't matter if it's a rectangle, a triangle, any of those things, we can do this. We'll be doing this on that quiz as well. So let's show you similar triangles, F1, F2, and they want to know what x equals. Well, x is this side right here, so let's just make that clear that this is x. And we don't know this side, so we can't compare these two, but we do know this side right here, so that will be our side 2. So let's set that up. Side 2, side 1, figure 1, figure 2. Set up our proportion bars here and start filling in the information. So from figure 1, we have 6 to 9. So 6 to 9. Figure 2 is x to 6. So x to 6. And again, you're going to cross multiply, turn it into an equation. 9 times x is 9 times x. 6 times 6 equals 36. To solve this, you divide both sides by 9. That way you isolate that variable x. X equals 36 divided by 9 is 4. There's supposed to be an equal sign there because 9 times 4 equals 36. So x equals 4. Then we try it and we find out 9. So this is our answer. X equals 4. We try it and find out 9 times x equals 36. 9 times blank equals 36. And we're saying x equals 4, and 9 times 4 does equal 36. So yes, x does equal 4, and that's our correct answer. So that's how we would do it on that quiz.